Hi, I'm Junjun, and this is Lab 7, and I will start from me to the first and part one. I will share my screen. So in part one, we're design a very simple neural network or MLP, completely from the using NumPy. I design the model in a modular way, separating the core MLP, MLP and um, training units and experiments. The MLP class includes weight initialization, forward propagation, loss calculation, and back propagation, uh, and also includes some like parameter uh, parameter updates in a gradient descent. It support both regression and classification, switching. Yeah, there are three example. First is the regression, and the second is um, second is the classification, and the third one is classification in like in three type. Yeah. So I am currently run the code. As we can see, in the first, in, as we can see, in all three experiments, the network performs well and trying in under like uh, 0. Uh, 0.6 seconds, and this result shows even a simple neural network can learn like nonlinear patterns efficiently. And uh, yeah, that's all in my in the part one. So I will pass to Rose.
Okay. Okay. So we did part two, in our local machine and in Google Colab. Now I'm not going to run this because this takes approximately like 1 hour, and in Google Lab it takes twice as long, almost twice as long. But basically, I will show you the results. So over here. We train our data 10 times, and then over here in my local PC, actually the accuracy is very low. That's around 50%. And then the evaluation time is 99 seconds. But in our Google Colab we get a better accuracy. Over here, it takes twice as long, and then we get a better accuracy over here of 99%. And then over here, the valuation time is around 63 seconds with just CPU. Okay, now I will just show you. So over here, I can run the part three. So over here, we can see that the device we're using is CUDA, and now it will train for 10 times, and it will give us the evaluation for each row. The training is actually taking a lot of time, but I think Dio over here will have a better rate, like better training time on the cloud. Yeah, so this is the final results for around 10 epochs, and now I'll pass it on to Dio.
Can we pause here?
Okay, so this is our result for 10 epochs. I will also run 15. Okay, and we can see once I run for 15 that the loss rate over here becomes much lesser. Uh, so the reason that can be is actually Dio gets a much better loss rate on 10 epochs. So the reason that can be is because my CPU, sorry, the GPU card is old. So that can be one reason, and another reason it could be that my because of it's an old GPU, the IO speed is less, and it can also be because of uneven data splits, I guess. Yeah. Yeah, so here we can see that the loss rate with more training, it becomes lower. So now I'm going to pass it on to Dio.
I'm gonna share my screen. Okay, so I'll start with our code from of part three. I will especially introduce our small changes on our model. And I want to introduce one is a function of called sigmoid. It turns the output from the ReLU output from scalar to the probability. And also we use optimizer called item. It is a common used optimizer in modern neural net training, and it's called adaptive moment is estimation. Basically it adaptive change the learning rates for every different ways from the previous gradients in the training part. And I will run our code on Google Cloud, and the graphic cards I use is NVIDIA Wave 100, and I will first show the default settings with 10 nipples. The batch size is 64, and the learning rate is 0.001. Yeah, they start with 0.01, and the learning rate is changing during the training because we use optimizer. And I will show the output from different batch size and the default learning rate to see if we can get a better performance. So in our test results, the accuracy is basically not over 80. Yeah, 80%. It's basically around 80%. I think it is maybe because the training side is only 20K. Yeah, maybe a larger data site may give a better performance. Yeah, and the sliding window we're using 3x3. Yeah. It's like a basic settings. Yes. And we can see the loss is much lower on cloud and Azure side. It's maybe because the device and the different I/O speed. Yeah. Okay, so after 10 inputs, the loss goes to 0.1 and the accuracy is around 78. And I will try different batch size. 128. And we can see even if we try different batch size and larger the inputs, the result is basically around 79 or 80, not over 80%. And we guess it's probably because there's no enough training data set. With a larger data set, the performance maybe be better. So that's all our Lab 7. Thank you.